At the hour of its send-off, NASA didn't understand that the Explorer mission would turn out to be one of the best space undertakings in history. The Explorer tests sent off during the 1970s have persistently observed Earth as well as everything inside our nearby planet group, and beyond. Regardless of having a memory limit 3 million times less than our cell phones and being multiple times slower than our quickest 5G web connection, these surprising space apparatus have furnished humankind with reliably new and astounding data about space. Now, Explorer 1 has made a startling revelation inside the depths of interstellar space, prompting the government to make the definitive move by shutting down this incredible mission. What precisely did Explorer 1 experience, and might we be very close to an extraterrestrial invasion? Let's find out. Among space missions, the Apollo mission takes the spotlight for successfully landing the first humans on the Moon. However, there is another exceptional mission that stands tall alongside Apollo, and that is the Explorer mission. This extraordinary undertaking not only holds the record for the longest enduring space mission but also has the distinction of being the first to explore the outer planets of our solar system, from Jupiter to Saturn, Uranus, and Neptune. The Explorer tests, specifically, are viewed as the most likely to encounter extraterrestrial life due to their extensive setup. Each Explorer spacecraft carries a special golden record containing a collection of sounds, images, and greetings from Earth, serving as a snapshot of humankind and showcasing Earth's rich diversity, a gift that any potential alien civilization could appreciate. But what if these striking tests were to encounter a hostile extraterrestrial race? From the signs we are currently receiving, this is potentially what Explorer 1 needs to deal with right now. This possibility has left researchers contemplating the potential outcomes, as such an encounter could prove more disastrous than initially imagined. Continue reading as we dive into the events that led to the government's decision to shut down Explorer 1 and explore the potential consequences. Before diving into those details, let's provide some significant context. On September 5, 1977, Explorer 1 embarked on its space odyssey from Cape Canaveral in Florida. It was launched into space by the Titan III Centaur rocket, just 15 days after its twin, Explorer 2, initiated its own celestial campaign on August 20, 1977. Their primary mission was to investigate the massive gas giants of our solar system, specifically Jupiter and Saturn, and their orbiting moons. However, these daring explorers surpassed all expectations by venturing deep into our cosmic neighborhood, breaking numerous records along the way. They have outlasted all other spacecraft in longevity and have traveled farther from Earth than any human-made object, even crossing the boundary of interstellar space and venturing into uncharted domains of our universe. As of now, Explorer 1 and Explorer 2 dwell more than 12 billion miles away from our planet, consistently surprising researchers with their incredible discoveries. Recently, they made an unexpected revelation that has captured the attention of the entire scientific community. The Explorer twin tests have achieved remarkable feats. More than 40 years ago, they revealed the enigmatic moons of Jupiter and Saturn, leaving researchers astounded. These celestial bodies, once thought to be dull and cratered like our own moon, were shown to be vibrant and dynamic. In 1986, Explorer 2 became the first and only spacecraft to venture into the realm of Uranus, quickly followed by an exhilarating encounter with Neptune just 3 years later. As these remarkable spacecraft continue their journey, NASA has implemented smart measures to ensure their operational longevity, including deactivating unnecessary components and conserving power, allowing the spacecraft to remain functional until at least 2030. The devoted researchers and engineers behind the Explorer missions were enthralled when a stunning discovery became known, so stunning that it prompted the government to intervene in what may be one of NASA's most prestigious projects. Before we discuss that, let's talk about the significance of the Explorer mission. Why is Explorer 1 such a big deal, and how has it transformed our understanding of space? Among the ranks of famous missions like Apollo 11, the Hubble Space Telescope, Mars rovers, and the James Webb Space Telescope, the remarkable Explorer program stands as a beacon of inspiration for future generations of scientists and space explorers. The data sent by the explorers has yielded valuable insights, sparked countless scientific revelations, and inspired the minds of researchers and space enthusiasts across ages. It's worth emphasizing that Explorer 1 and Explorer 2 were no ordinary spacecraft. They were meticulously designed to operate as steady platforms, with a rotation rate more than 60 times slower than the hour hand of a clock. This deliberate design ensured minimal blurring of images and data as the spacecraft traversed the vast expanse of space. Their remarkable imaging capabilities continued to astonish researchers and the public alike. Even before their encounters with the outer planets, as the spacecraft approached Jupiter, they began transmitting pictures well before reaching the gas giant. These initial images, showcasing swirling clouds and the famous Great Red Spot, filled NASA's Jet Propulsion Laboratory with pure excitement. However, it was the discovery of dynamic volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, emerged as the most volcanically active body in our entire solar system. The spacecraft's instruments detected unusual signals emanating from Io, and subsequent images confirmed these remarkable findings. The pictures revealed towering volcanic plumes and a surface marked by volcanic material ejections. Notably, one of Io's prominent volcanoes, Pele, erupted to heights exceeding Mount Everest by an astounding 20 times, covering an area nearly the size of France. In total, the Explorer spacecraft captured over 33,000 pictures of Jupiter and its moons, revealing the planet's breathtaking beauty and the astonishing diversity of Jovian moon landscapes. Before delving into the latest stunning revelation, it's crucial to remember that the twin explorers have been uncovering a wealth of extraordinary discoveries since their groundbreaking launch. One of the most surprising revelations was the presence of Jupiter's rings, which, although faint, added another layer of intrigue to the mission. Titanic gas Goliath, and the Explorer 2, divulged the frigid shell wrapping Europa, one of Jupiter's 50-odd named moons. Assessed to have a thickness outperforming 60 miles, these pivotal discoveries tested recently held suspicions about these far-off divine bodies, igniting a re-established enthusiasm in researching the expected tenability of frosty moons. As the explorers bid an affectionate goodbye to Jupiter, they appreciatively got a gravity assist that gave them a fundamental lift, driving them towards the captivating domain of Saturn. Without this shrewd move, their escape from the Sun's gravitational pull and their ensuing journey into the profundities of space could never have been conceivable. Thus, Explorer 1 and Explorer 2 left on discrete directions, each wandering towards strange outskirts, anxiously looking for new wonders to unravel. Explorer 1 set out on a trajectory that took it close to Saturn's moon Titan, which is encircled by a dim orange atmosphere. Researchers became captivated by the mystery surrounding this moon, inciting them to conduct further studies on its complex science. Explorer 2 then took a different path and headed north, creating some distance from the plane of the planets, starting its exceptional excursion past the limits of our solar system. In the meantime, Explorer 2 embarked on an astonishing series of undertakings that conveyed it to the outer planets of our solar neighborhood. In 1986, it accomplished a notable achievement by flying by Uranus, where it startlingly found 10 previously unknown moons, expanding the moon count of this planet. 3 years later, Explorer 2 arrived at Neptune, uncovering the unprecedented qualities of this far-off ice giant. During its encounter with Neptune, the spacecraft recorded wind speeds of up to 1,000 miles per hour, marking the fastest winds ever observed on a planet within our solar system. By zooming within 2,980 miles of Neptune's methane atmosphere with its sky-blue tint, Explorer 2 provided unparalleled insights into this distant world. Triton, Neptune's largest moon, ended up being one of the coldest places in our solar neighborhood, with surface temperatures dropping to a frigid -391 degrees Fahrenheit. Triton also had distinctive features, such as ice volcanoes shooting nitrogen gas and frosty particles up to 5 miles high into its thin atmosphere. These discoveries expanded our understanding of the amazing variety and complexity of celestial bodies, extending even to the farthest reaches of our solar neighborhood. One person who played a vital role in extending the missions beyond their initial goals was the renowned astronomer Carl Sagan. As a member of the Voyager mission's imaging team, he energetically pushed for capturing one last series of pictures before deactivating the cameras on both spacecraft. These pictures would serve as a keepsake to humanity, providing a final glimpse of our home planet from the distant reaches of space. Sagan's persistence paid off on Valentine's Day in 1990, when Voyager 1 turned its camera back towards the inner solar system and took a series of 60 photos. The most iconic of these images, known as the pale blue dot, remains a profound symbol of our place in the universe, captured from an astonishing distance of 3.8 billion miles. Earth appears as a small pale blue dot, barely discernible in the vast expanse of space. This mission has been ongoing for almost 50 years, leading many to compare it with later space missions. One such mission that has made significant scientific contributions is the James Webb Space Telescope, JWST. Although their goals and scopes differ, both missions have pushed the boundaries of human knowledge and expanded our understanding of the universe. The Voyager spacecraft were marvels of their time, equipped with state-of-the-art instruments and systems that allowed them to withstand harsh conditions and maintain communication with Earth across vast distances. Similarly, the JWST integrates cutting-edge technology to continue the exploration of the cosmos. Innovations like a deployable sun shield to safeguard its sensitive instruments from the sun's intensity and an enormous section mirror to catch faint infrared signals characterize the Explorer program. While the JWST intends to disentangle the secrets of the universe on a more extensive scale, its high-level abilities will empower researchers to peer back in time, noticing the earliest universes and revealing insights into the development and advancement of our astronomical climate. What techniques were utilized to ensure the progress of the Explorer missions? Envision almost 50 years ago, in August and September 1977, NASA embarked on a fantastic mission that would forever change how we understand the universe. With steady assurance, they launched a couple of spacecraft into the vastness of space, equipped with a revolutionary technique known as gravity assist. These maneuvers proved to be the key that unlocked the secrets of the solar system and pushed humanity into the realm of the unexplored. Picture this, an incredible dance where the spacecraft nimbly embraced the gravitational forces of the giant planets, harnessing their power to slingshot themselves toward their intended destinations. Instead of relying solely on their own engines, the explorers skillfully used the massive pool of the cosmic giants to propel themselves across the vast expanse. It was a brilliant idea and a clever move that conserved valuable fuel and propelled the spacecraft with remarkable speed, enabling them to embark on a grand tour of the solar system. At the heart of this method lies the concept of gravity assist, also known as the gravitational slingshot. As Explorer 1 approached Jupiter, a majestic gas giant with gravitational forces that defy comprehension, it required meticulous accuracy to coordinate the perfect encounter. With extreme precision, Explorer 1 gracefully swung around Jupiter, harnessing its gravitational pull to accelerate the spacecraft with a tremendous burst of speed. This propelled it further into the depths of space. Executing such a maneuver demanded an extraordinary level of expertise. These gravity assists became the driving force behind the remarkable journey of Explorer 1 and Explorer 2 through our solar system. Consider the incredible achievements made possible by these slingshot maneuvers. Explorer 2, propelled by gravity assists from Jupiter and Saturn, embarked on a truly remarkable journey to Uranus and Neptune, completing the grand tour. It was a triumph of human ingenuity and exploration, owing a tremendous debt to the precision and skill involved in these gravity assists. Explorer 1, venturing boldly into interstellar space, was closely followed by Explorer 2. Both were driven by the infinite pushes provided by these maneuvers. The concept of gravity assists may seem deceptively simple, but its execution is a testament to the brilliance and dedication of the people behind these missions. The grand tour undertaken by Explorer 2 demanded meticulous precision, where missing even a single slingshot could have meant disaster for the mission. Yet, with enduring determination, these pioneers of exploration pushed the boundaries of what humanity could achieve, driven by an insatiable thirst for knowledge and a deep desire to unravel the secrets of the universe. While gravity assist maneuvers played a crucial role in exploring the universe during the Explorer missions, they were not alone in ensuring the success of these ambitious endeavors. Enter the Deep Space Network, DSN, a support system that connected us to our intrepid Explorer probes as they ventured into uncharted territories. Consider it the Interstellar Communication Network, a tapestry of enormous radio antennas strategically positioned across the globe. These grand dishes, ranging from 26 to an impressive 70 meters in diameter, served as colossal ears, enabling vital communication with the spacecraft beyond our planet. Imagine the Explorer mission as a grand odyssey, driven by a remarkable curiosity that transcends reality. The 8-track tape, a striking artifact, serves as a monumental time capsule, housing valuable scientific data as it journeys through the vastness of the universe. Unlike standard consumer tapes, the 8-track recorders used on the Explorer missions were a marvel of engineering, featuring a reel-to-reel storage system designed by Lockheed and manufactured by ODC Enterprises. These remarkable machines boasted specific capabilities, offering recording speeds of 115.2 kilobits per second, kbps, and 7.2 kbps, while playback speeds ranged from a maximum of 57.6 kbps to slower options of 33.6, 21.6, and 7.2 kbps. The reliance on these extraordinary 8-track recording devices within the Explorer mission embodies humanity's unwavering commitment to scientific exploration. As these probes venture deeper into the universe, the enduring legacy of this immortal artifact continues to safeguard and disseminate our unquenchable thirst for knowledge. The Explorer missions have sparked wonder and curiosity in all of us, preparing us to journey into the vastness of interstellar space. However, before we delve into the revelations that led to the conclusion of Explorer 1, let's examine other fascinating interstellar missions: Pioneer 10, Pioneer 11, and New Horizons. These missions have played a crucial role in expanding our understanding of the solar system and beyond. Picture this: it's March 2, 1972, and Pioneer 10 launches on its historic journey. It becomes the first spacecraft to venture beyond the asteroid belt, traveling into the unknown regions of the outer solar system. Its mission included flybys of Jupiter and its enigmatic moons. On December 3, 1973, Pioneer 10 achieved an unprecedented milestone as it became the first human-made object to travel through the asteroid belt, offering us valuable insights into this mysterious region of space. But the excitement doesn't end there. Pioneer 10 astounds us with stunning images and crucial scientific data as it performs a close flyby of Jupiter, capturing the essence of the gas giant and its captivating moons. Pushing further into the unknown, Pioneer 10 becomes the first spacecraft to cross Neptune's orbit in June 1983, etching its name in history. Although contact with Pioneer 10 was lost in 2003, it remains a pioneer, the first man-made object to venture into interstellar space. Following in Pioneer 10's footsteps, Pioneer 11 takes the stage on April 5, 1973, with similar objectives. It embarks on a challenging journey, and on December 2, 1974,